Hello everyone, welcome to AI Anytime channel. In this video, we are going to build something called Chat with CSV bot, okay, using Llama 2 model. So Llama 2 is a new large language model that has been, released by Meta AI, which is an open source and commercially available LLM, and that's what we are going to use in this video. So I have one more video on Llama 2, that I have created a few days ago. You can see this build and run a medical chatbot using Llama 2 on CPU machine, all open source, and that's what we are going to do in this video as well. That we will load this Llama 2 model from Hugging Face Spaces. So I have downloaded the quantized model from the block repository on Hugging Face. Tom Jobbins is the creator of the block repository on Hugging Face, and Tom Jobbins is one of the most important guy, I will say, in the open source community right now, who works on LLM quantization and ops. And we are going to leverage one of the GGML model, okay, and that model we are going to load it through something called C transformers. So I will quickly write what are the things that we need and what are the things that we have to consider in this video, right? The first thing that we have look at the quantized LLM. This is the model that we are going to use in this, and in this case it's Llama 2 GGML model. The block also has GPTQA model on Hugging Face, but I'm gonna use GGML model for this video, which at least works good for me right now, and for few of the use cases I have tried, and it works well. And it's a GGML model which runs on commodity hardware like single consumer GPU or on CPU machines as well. So I am going to run this on 16 GB RAM CPU machine, and that's what I'm gonna do, okay, on the quantized LLM. And to load this model, we need something called C transformers, okay, which is a C++ binding, the Python binding of in C++, like to load transformers based model. Okay, so this is how we're going to load the model. So we're going to load the model not from transformer but from C transformer. These are the two things which require for CPU machine, because we are going to run this on a limited compute devices like CPU. And Andres Karpathy has released on Llama Z, right, baby Llama, which runs on through a single C file, and that's what we need. We don't need these models to run on GPUs, to be honest. And we have to look at the smaller models or the domain specific model in near future, and that's what a lot of models, like we are seeing a lot of models which are coming are having less parameters, and they're performing good. There has model like Phi1, Orca, and Cerebrum, a lot of other models which has less parameters and have seen good progress on the performance standpoint. So these are the couple of things that we need to run this on a CPU machine. And what else we need here is that, okay, we need sentence transformer. So let me write sentence transformers, again a model which is available on Hugging Face. We're gonna use all mini LM LV6 or something. Okay, this is the model that we are going to use. Okay, version 6 language model, or V2 or something. We have to see that. Okay, this is the model that we're going to use for create the embeddings, okay, on your data. Okay, so this is for embeddings. So let me just write it over here. Okay, I'm just going to write it for embeddings. And once you create the embeddings, you have to save that embedding somewhere. I'm going to store that in a vector store. And in this video, I'm going to rely on faiss CPU. Faiss is again by Facebook. I have to give credit to Facebook guys, Meta AI. They have been very instrumental to strengthen this open source community. Okay, it's the race between open source and closed source nowadays, with Claude, Bard, and GPT's model that are coming out through closed source, through commercially available APIs. But Facebook or Meta AI nowadays has done great job, to strengthen the open source community. And so we are going to use faiss CPU, okay, at the vector store. But if you want to use, you can use Chroma. Make sure that when you are using Chroma, you have to look at the Chroma settings. Nowadays they have migrated from DuckDB to SQLite. So if you are getting any error, you can look at that. You don't have to use DuckDB now for that one. Now the vector store, and here it comes, LangChain for all the heavy lifting. So we'll use, some chains here, guys. I'm gonna write chains here, okay, very quickly. So these are the things that we need, right? We need LangChain, vector store, sentence transformer, and couple of other things that to run this in CPU machine. And the last thing is Streamlit. Okay, we're gonna use Streamlit and Streamlit Chat. So Streamlit Chat is a library for chatbot interfaces or conversational interfaces within an Streamlit application. So these are the requirements, prerequisite for this tutorial video. And I will be a little fast in this video, guys, because if you really want to understand, you can watch my 1 hour video. This video I have used Chainlit to create a medical bot using Llama 2. So if you want to really understand a little bit in details, you can go through that video. And in this video, chat with CSV. So we are going to use something. Let me also explain that, guys. A very simple thing. So when I say LangChain, so here in LangChain, what I'm going to do is we are going to use CSV loader. So I'm going to use CSV loader here to load my CSV data. Now you can also look at something called unstructured files or loader. If it's not deprecated, you can look at unstructured files as well in LangChain. I'm going to use CSV loader to get this CSV data, and I will have I like to do everything on fly. Okay, so when I say fly, I will let user upload the CSV file on the Streamlit interface, and then the embeddings will be created on fly, because I will have a simple CSV or a spreadsheet. But you can also have complex and multiple CSV. It depends. You can extend this further, right? So let's jump in and start writing some code, guys. So I'll just start writing the code here. So let me just do one thing. Let me create a new folder here, and in this folder I'm gonna call it chat CSV Llama 2 or something like this, and I'll just go inside chat CSV Llama 2, and here I have Llama 2 demo. I need this file, so I'll just copy this file, Llama 2 7b ggml model file. So I need this model. You can see it's .bin. This is the chat. It's a 7b model. Llama has models in 3 different categories, and I'm going to use the lowest weight the parameters there, which is 7b. So now let's do one thing. So here within this, I'm going to open this in terminal, and once I open this in terminal, I'm going to activate my LangChain environment. Within that, I have installed all the required dependencies. You will get the dependencies from my GitHub repository. Don't worry about it. Now, conda activate LangChain. Let's open this in VS Code. Now, once I open this in VS Code, let me just do something here. Okay, and I'm just going to create a file called app.py here quickly. And within this app.py, let's import a few things. Import Streamlit as st. That's the first thing that I need. Then I need from Streamlit Chat. So Streamlit Chat is a library that helps us create conversational interfaces within a Streamlit app, and I'm gonna use masses here. Let me show you also what I mean by Streamlit Chat. So I'm just gonna say Streamlit Chat GitHub. Someone like AIS has created this. Credit to him. All credit goes to him for creating this wonderful library. And you can also explore that further in some of your other applications as well. So let me also have my AI anytime GitHub open here, just in case we need this Llama code from medical chatbot. A couple of functions there, guys, quickly, and I'll just open model py here. Anyway, now let's come back. We are okay with a couple of Streamlit dependencies. Now I also need temporary files, so let me call it temp file, import temp file, and I also need now LangChain thingy. So from LangChain, document underscore loaders. As I said, I'm going to use CSV loaders here in this case. Loaders, I think it's dot CSV loader, yes, and then import CSV, yes, the first one. Here we go. So this, we will use this to load our file, load the CSV file, guys, and then is from LangChain dot embeddings. And I'm going to use Hugging Face embedding in this case. So let me just use Hugging Face embeddings. If you are facing any challenges with Hugging Face embeddings, you can also get sentence transformers embeddings there. It's also available directly in LangChain. Okay, and now we have to store that embeddings in a vector store, and for that we're gonna use faiss here. So from langchain dot vector stores, and then I'm gonna use import faiss. That's it. This makes sense. Now the next thing is from langchain dot LLMs, I'm gonna use C transformers to load the model. And last thing is we need a chain to basically retrieve or have some conversations. I'm going to use conversational retrieval chain or something like that. So from langchain.chains, I'm going to use import conversational retrieval chain. We are done with our import, guys. Okay, now if we want to, for example, if you have multiple files and if you have bigger files, and once you are creating the embedding, you want to basically store that locally, right, somewhere in the folder, right? You don't want to load, basically create the embeddings every time to have the interactions if you're not changing your file. So for that, in that case, it's better to have a folder where you can save your this thingy, the embeddings. So dv faiss path, and let me give you a path called something like, you know, vector store or something. Okay, vector store dv underscore faiss, something like this. Okay, we are okay with it. Now let's load the model, guys. I'm just gonna write it loading the model here, and within this I'm gonna use the C transformers function from my previous video, and you can see here is a code, and a simple thing. I'll explain what we are doing here. C transformer is a fantastic library, and also you can look at VLLM as well if you want to load transformer based model faster. So let me just come here and say C transformers GitHub, and you can see that it's by Marilla. C transformers again, Marilla, thank you so much for creating this wonderful library. And you can see it says Python bindings for the transformer models implemented in C and C++ using GGML library, and it's fantastic, right? And it helps you load the model and inference it faster. Okay, so we are okay with it, and you can see that we are getting this Llama 27B chat GGML version 3 quantized 8 being something like that. Okay, if you want to use any other model from the block, let me quickly show you what I mean by it. The block hugging face. What would we have done if there is no block? That's even very scary to think about it, right? You can see Tom Jobbins. He works with LLM quantization fine tuning, and so many models, right? More than 600 models. Block has, Tom Jobbins has itself, you know, quantized, and you can find all the models over here. And the model. Let me show you Llama, the model. You can see here is the Llama 27B chat GGML. Now you can go to files and versions. And when you files and versions, you can download these files. I'm using the large file over here. You can see this 7.16 GB large file LFS, Git LFS, quantized 8-bin. Now depending upon what model you want to use, if you're interested in using any other models, please go ahead and use it. Make sure that you change the model type. For example, if you're using a Vicuna model, you have to make Vicuna. If you're using an alpaca model, you have to change all those files. You make sure that C transformer is supporting that. You know, you can find that on the GitHub repository. Anyway, now we are okay with our model load, guys. Now we have a function that will load the model. Let's write something like, you know, your title. What should we write over here? Chat with CSV. Excuse me. Chat with CSV. Using Llama 2. Okay, now this is what my title is. I'm gonna use a markdown here, guys, also. So let me just go back to my GitHub repository again, and you know, I'll go within, I'll see if I have something. A chat with PDF. I need that header there, guys. Okay, so let me see that quickly. Some markdown file. You can see this markdown will do. I don't want to write a lot of code in this video on these things, at least. So you can see here is our markdown. Let me do an Alt G, and when I do that, built by AI anytime, let me change the gray. Streamlit supports markdown. You can make a lot of changes on the design aspect. You have to write that in markdown, and then you have to say unsafe allow HTML true. Okay, now I'll just make this color as white. That's it. Okay, there is some issues with the indentation. Let me just make it right. Okay, now this, we are done with it. Let's have something called uploaded file here, a variable that will store our file. So what I'm going to do here is ht.sidebar, and in that sidebar, let's have a file uploader. So let me just do file uploader, and in this case, I'm going to hit upload your data or data, whatever you call it. Okay, and type. Let's give a type for extension, right? So we're looking at CSV in this case. Let me just do one thing, and here, and let me do run this app, Streamlit run app.py. Once I hit enter, it will open in a new tab in the browser, guys. You can see on port 8501. It looks good, by the way. So we have chat with CSV using Llama 2, built by AI anytime with love. And in the left hand side, you see the user, the end user, the people who wants to use this app. They can upload the file, a CSV file over here, and then we will write the code for processing. Let me see if I have something like Llama icon GitHub or something like this. Okay, I want to use some I want to use some icons to make it little so it looks a little good, right? So let me just put something here in the thingy over here. Can we get a for parrot as well for LangChain? So parrot emoji. Yeah, I need this emoji for LangChain, and I'll just put it over there. Okay. Now if I just do a rerun over here, you will see that we get it looks nice, right? We are having llama emoji over there. Now we will like to have user upload their files over here, and once they upload the file, we'll create the embeddings on fly, and then we'll have a interface over here, where the user can interact. Let's write the code for it, guys, quickly. Now very simple thing. Now we have uploaded file. So let's say if there's uploaded file within it, you can also do none or something. Okay, you can just do it, play around with. I'm not focusing more on Streamlit in this video, guys. So uploaded file, and let's use with temp file. So we're saying, okay, temp file, temporary file, named temporary file. If there is already, delete. So let's call it false for now. Delete false as tmp or something like this. Okay, tmp file. This will also help you when you have multiple CSVs and you want to return the source document. This will help you also, right, to retrieve that. So tmp file dot, and anyway we have to probably we have to show that. Maybe if you want to show it on Streamlit, you have to save it and show it or something like this. Okay, so uploaded file, let's get value. So let's get value of this. It's a function, so get the value of it. The reason is that CSV loader only accepts the file path. Okay, that's why we are doing this to feed it to the CSV loader in LangChain. Now temp file, tmp file, let's give it a variable called path, and then just tmp file dot name or something like this. Okay, tmp file dot name. That's it. We are done with this, guys. Now what I'm going to do here is I'm going to have a loader variable, pretty much straightforward from LangChain documentation, right? We'll have a CSV loader that we have imported. If you want to use directory loader, do it. If you want to use PyPDF loader, do it. If you want to use any other type of loader, please do it. Depends on what kind of data that you have. Okay. Now on CSV loader, what I'm going to do here is I'm going to have something called file path, and my file path is nothing but tmp file path in the above line that we have written. Let's give a encoding for CSV UTF-8 in this case. So UTF-8 and couple of other arguments for CSV. CSV arg, it's a dictionary key value pair. Let's write a delimiter, guys, here. In this case, if your CSV is not properly in a proper format, you might get some error there, right? So let's have a delimiter, and in that let's write something like how I think it's comma. So let's do that. Okay, now delimiter is done, and I think we are okay with this. So we are okay with our loader, guys. Now what I'm going to do here, data, let's load that data first, of course. Loader.load from LangChain. So I'm going to do loader.load here, and once I do loader.load, let's first print that data, and I'm going to call it data for now, and let's see if we are getting any error here. Okay, now let's run this and see, guys. So I think we are okay with delimiter and this thingy, the CSVs and all. So on browse file, I need a CSV file. So which file I can take? I think I have let me just go back. I already have a Pandas AI bot that I built 2 months back. This video is also available on my GitHub repository, where I have used Pandas AI, some libraries with GPT integration in Pandas. I'm gonna use this file, this file that I'll download it quickly. It's a GDP file for countries. I've just downloaded it somewhere. Okay, and now let's click on browse file, on downloads, click on, I already have this file. Cool. Okay, Fine. So now we have data equals to loader.load. Now what we're gonna do is we're gonna create an embedding. So let's create an embedding for it. So very quickly I'm gonna write embeddings, and in that embeddings equals what I'm gonna write here is embeddings equal Hugging Face embeddings, and within this embedding I'm gonna write the model name. So our model name is nothing but sentence transformer. So let me just write sentence transformers. Let me just get it from there, or maybe I can write it all, or let me just take it from my previous video. Okay, I'm gonna go on this Llama to medical chatbot, and I'll take it from model.py, and here you can see, where do I see, here it goes. Okay, let me just copy these embeddings from here quickly, and I'll just remove all this thing and I'll paste it over there. So embeddings, I'm okay with embeddings now. You can see that we have our embeddings, model name, and yeah, so sentence transformer, we have device CPU because we want to use it on CPU, right? So we are okay with, we are using all mini LM L6 V2 version 2 or L6. What did I write in the cast? Sorry, I wrote V6. No, it's version 2 L6. And we are okay with our embeddings now. So let's have a DB, and in that DB I'm gonna use faiss, and then from documents. So in from documents, and I'm gonna pass my data, which is nothing but the CSV that we have, and we are passing this embeddings which contains our sentence transformer embeddings model. That's it. So DB. Now what you can also do, you can also save this if you want to. Let's write the code for it. It depends. Save local, and then we have DB path, DB faiss path that we have defined on top here. You can see we have this DB faiss path, right? That's it. So it's okay. Now we are saving that as embedding. So let's call this LLM now. So I'm going to use LLM, and I'm going to use this function load LLM, because we have to pass that within a conversational retrieval chain or something like that. Let's create that chain, and in this chain I'm going to call it conversational retrieval chain. You can see it over here. We also have imported on top over here. You can see that, and which is dot from LLM, and within this I'm going to pass my LLM equals LLM, and then I'm going to pass the retriever equals DB dot as retriever. Yes, that's it, which is the function, which is right. Now I have written the function so far which has created the chain now. So we have to pass the query within that chain to get the response from LLM based on the embeddings that we have created. Now let's write the function for Streamlit chat. Okay, so I'm just gonna write first function called conversational chat, and within this function I'm gonna have my query. This will contain my query, the query that end user will write on the Streamlit interface. Let's have a variable called result. So let me just do result, and within this result I'm gonna use a chain, and in this chain it's a key value pair, so it has question. So question is nothing but it's query, and then after query let's also have a chat history that's in a conversational retrieval chain. So in chat history you can also show it, the chat history and all if you want to show it. I will have a ht.session state of Streamlit, ht.session state, and then I'm going to pass my history here. That's it. So history, that's okay. Now we are done with this. So now let's have ht.session state here. So for history, so ht.session state, and then I'm going to call it a history, and in this history dot append, we'll append all the responses in that. In append, and again then we'll pass query, and then we'll write result. So we'll get this result. Okay, so let me result, and I think it's Llama has answer. Fine, that's it. Now we are okay with it. So chat history, this looks nice. Query, append, query, result, and that's it. So now let's return this. So what I'm going to do is I'm going to do a return result and answer. So let's for now return this. Okay, and here I can see that I have made a mistake. It's query, not dot, it's comma, by the way. Sorry. Okay, fine. Now we have conversational. So now let's handle the session state. Okay, if it's history, if it's newly generated, if it's past, right? So we'll have three conditions, three conditional. The first conditional is if history not in session state, then execute the below code within this. Okay, and that is very simple. st.session state history equals nothing there, and that's what we are appending, right? On conversational chat function over, you can see history.append. Now if generated not in session state, st.session state, sorry, st.session state, then st.session state generated equals, let's have a welcome message or some message there, right? So it's inside a list. We'll write hello, ask me anything about something like, you know, about we'll have this data name. So let's call it uploaded file dot I think it's uploaded file, yes, uploaded file dot name. And what can we have here? Okay, so we can have okay, let's have this exclamation marks for now. Okay, so exclamation mark. Okay, it's not marks, mark. Now the last if condition will be the past response. Okay, so the previous one. So if past not in st.session state, then we'll have st.session state past. Just hey, this is the first line on the left hand side, right? Hey, something like this. Let's use some emojis. So let me just go to GitHub emojis quickly, and I'm search for GitHub emoji or something like this. Okay, so it has emoji cheat sheet. I need some emojis, guys, you know, just to make it really. So many emojis are there. Okay, so let's have this for. I don't know if I can copy it. I just want to put it over there. Oh, I just need that emoji. Okay, so let me just go back here on the emoji cheat sheet, and let's see what I'm getting. Yeah, now I'll keep this as 1. So let's keep this here within this, and 1 of waving the hand or something like that. Okay, where is that? Here we go, wave. Okay, this we can copy it. You can also, and we can pull it over there or something like this. Okay, it says wave. I didn't copy. If I have to copy wave, I'll probably copy this. So let's copy in the same emoji format and see if it supports. I'm not sure about it. I don't know why I'm not able to copy it, but anyway, I'll just paste and see if marked. But I don't see that st.session understand that. But anyway, we'll keep this for now and we'll check it. Now we are done with this. So what I'm going to write now next is we need to create a container for the chat history, right? So let me just write container for the chat history. So container for the chat history, and let's have a response container. And within this response container, st.container, and this is okay, and then container dot st dot, this container is for the user's text input, because we are going to have a form that's where we'll take the input. So container is st.container, Streamlit container. We are using a Streamlit container. You can go through Streamlit documentation for more detail, guys. Now with container, not create, with container, I'm going to have a forms. So with st.form, and I'll give a key to this form, and key is nothing but, for example, let's call it, you know, like in HTML we have my form or something. Okay, my file or whatever input, my form, and clear it. So clear on submit, right? So let's call it true for now. Clear on submit true, and I don't know if we should do it. And then we have user input. So let's have our user input, and the user input is nothing but st.text input, guys. And in st.text input, I'm gonna have a query which will have a placeholder, by the way, query, and then placeholder. And this placeholder is nothing but talk to your CSV data or something. Okay, let me just write talk to your CSV data, and talk to your CSV data here, and then we can use some other emojis as well if you want. And or something like this. Okay, and then let's call key equals input, key equals input, and this closes it, and then we'll have a submit button here. So let's have a submit button so that user will hit on that to retrieve the answer, and I'm gonna call it st.form submit button. Yes, st.form submit button, and it should have a label there. So let's call this label as chat or something like this. Okay, chat. Now this makes sense. Now so we have two variables there, so let's just get that variable. So use that variable. So what I'm going to do here is if, now let's come out of that with loop. Now what I'm going to do here is if user input, or first we should have if submit button and user input both have been given. Okay, and if submit and user input both have been given, then you execute you get an output, use that conversational chat function. So we have this conversational chat function, and in this conversational chat I'm gonna pass my user input. That's it. So this will have our user input, and then we have st.session state, and the first is passed, and that start appending it, right? So the first append with user input. So if this is for the first time in the past, and then st.session state, not future, it's generated. So generated, and this should append the output. So the past will append the user input, and the generator will append the response or the output. So we are okay with it. Now come out of that with with container, and if st.session state generated, so let me just write generated, then with response container for I in range length of that session state. Yeah, this is okay, this is what I need. Let me just close this. Excuse me. If length of the session generated, and couple of, okay, this will close here. Fine. For I in range length of st.session state, then print the message in Streamlit chat. So message st.session state, and in that it will be passed, and the first two, so let's is I, and then is user true, and let's key equals string I, and then underscore user in that session, and we can also pass something called avatar style. Okay, so in avatar style, let's have a big smile or something like this. So we have an avatar style in that Streamlit chat message function, big smile, and then let's have the final message for generated one. This was for the past one, the previous past, and the next one is the generated. So generated I, and it will not have is user true. So generated I, and it will only have key, and then it will have string I and not user. It will just, let's give an avatar here. So avatar style and thumbs. That's it. That's what we need. So we are done with our code, guys. Okay, so avatar style, a thumbs, it's fine, it's okay. I don't know why I've given plus here. It will not be plus, it's just comma. Okay, now we are okay with our code here, guys. So I'll just explain quickly from top to bottom before running this application or the bot that we have created. Now we have imported all the required libraries. You can see we have a faiss path or a vector store path where we'll store our created and generated embeddings, and then we are loading the model using C transformers, GGML model, model type Llama, max new token 512, temperature 0.5. You can customize the hyperparameter. I'm not going to do that. And then I have some titles, markdown, etc. for the Streamlit app. Then I have a file uploader in the left hand side sidebar on the Streamlit, where user will upload a CSV file. Then I am saving that file locally. I have to save that. Okay, I can write it and get the value, and then you need a temporary file path. That's because CSV loader needs the file path. You can see that we are passing that file path, TMP file path, and we are passing some CSV arguments within that. Then we have loader.load to load that with the LangChain function. Then we are creating the vectors, the embeddings, using sentence transformers, one of the most used open source model for embeddings. And then I have faiss from documents. If you want to use chroma, that will be chroma from documents. If you want to use qdrant, milverse, etc., you can do that. Now I'm saving that locally in db faiss path. I'm loading the LLM, so it's LLM equals to load LLM, and then I have a chain, conversational retrieval chain. If you want to only use retrieval QA, you can also do that. You can also only use LLM chain as well if you want. So I'm using conversational retrieval chain, passing the LLM and passing the retriever, which is db.asRetriever. Then writing a function which takes query from the end user, passing the question within the chain with a chat history, and chat history is coming from the session state within Streamlit, appending the session state history with the answer and just returning the result answer to the user so it can show it. Now we have three conditions. The first condition, if history not in the session state, then have an empty list. If generated, which is the output that model will generate, okay, not in session state, then generated hello, ask me anything about an upload file name and something like this, right? File name and some emoji, and then we have for past as well. And then we have creating a container for chat history, and then we are using container ht container with container, and we have a form where user will submit their this query, user input. Then we have a submit button, and we are checking if both the values are there. Like if there is a value is inside user input, you can also do length user input and do it. Then output equals to using that function conversational chat, and then just appending it, and we're just checking in the last and printing the message. That's what we are doing, right guys, in this thingy here. Now let's go back and run this, upload some file, and see if this is giving us the right response. So once you go back here, right, on the this tab in the browser which already have chat with CSV, let's just do a refresh here, chat with CSV using Llama 2 built by AI anytime or something like that, right? And you have upload your data where you can upload your data. So let's upload this data and see if we are getting any error. Now once we upload our data, you can see we have something called hey, hello, ask me anything about your file name. So you are uploading this file name, and we have this conversational interface within a Streamlit app, okay, which is inside a container, right? A Streamlit container. This is the container that we call it, and where we have a form where you can pass your query, talk to your CSV data, something like this, right here. That's what you can do. Now this is the let me just show you the data quickly, guys. This data is also available on Kaggle. You can explore that from Kaggle itself, okay, if you want. And I'll show it to you. It has this data about countries and their GDP, their score, social support, health, life expectancy, freedom to make life choices, blah blah blah, right? So basically how happy a country is, you can find out based on these parameters within that data, right? So now this is a simple CSV file. You can have thousands of CSV files. You can have different type of questions. You can check the complexity level of the model understanding as well, how good reason it is on your data, and a lot of other things as well, guys. So let me just ask a question. I'm gonna ask a question like, for example, which country, or let me ask, what is the GDP of the China or something? What is the GDP of China? This is my first question. This is the question I want to, or this is the query that I am making, to the model, and I'm assuming that okay, it will retrieve the information for me. Okay, so let's ask this. Now once I click on send, you can see it says it's running. Now as we are using a Llama 2 here on a CPU machine, I'm not expecting that this will give me a response within 10 seconds. It will take you time, okay. With this one, it might take up to a minute as well, depending on what kind of machine you have and how big your embeddings and the similar chunks that it retrieve, right? The model retrieve, because it has to process all those chunks from the embeddings and find out the relevant information for you, right? So it will take little time. Meanwhile, just to give you some information on this, guys, I some of you have requested that I should create chat with CSV using Llama 2, so I thought okay, I'll create this video, okay, and how you can load a CSV file and how you can create it with a similar way, right? Like a normal chatbot. So you can also create a mechanism for batch processing where you can upload multiple CSV files and you can run some queries on top of it, right? And you can do through a batch processing, so you don't have to wait in real time to get the response. So, and probably if you have compute power to deploy this kind of bots, to for real time, interactions, you can also do that. So the code will be available on the GitHub repository. You can find out all the code snippets for this, and you can see that the GDP of China is 1.029 trillion dollar, something like that. Okay, the GDP of China, right? This is what. Let's ask which country has the least GDP according to the data set, according to the data, something like this. Okay, I'll ask this question again. So it took around 30 to 40 seconds for response, which is fairly good, I'll say, on a CPU machine. So I'm running it on a CPU, but I do have a GPU in my this current system, but I just wanted to create this on CPU because most of you have suggested that, okay, or most of you have requested rather that how we can run it on a CPU machine, because not everyone has a GPU. Okay, now, so the code will be available on the same GitHub repository, and you can also find my code for this video as well. Develop a medical bot on CPU machine using Llama 2. That's also available. You can just go ahead and get it. And so you can also do source document or something like that to get the row, basically, because it's an Excel sheet. It will give you row. You just have to write that logic there. You can also put some validation checks with Pydantic or with guardrails AI. There's a library in Python. You can put some certain guardrails and some validation check to find out if you are getting your data or the responses from the same Excel that you have uploaded. Because I do believe that because we are not writing any custom prompts, so if I ask here in this bot, okay, tell me more about the GDP of China, it will basically give me some garbage response or some response outside of this embeddings or the PDF, because we are not using this context mechanism or the custom prompt templating in LangChain. But anyway, so let's wait for this response because I want to show you live that this works. It's not a static page, okay, but the potential is immense, guys, right? Chat with CSV, or you put some speech to text and text to speech in this, you make it completely automated, right, end to end. And you can write some Python script that will connect with your SharePoint, connect with your databases, feed all the data from there, scrap all the data from, or collect all the data from there, then pass it to LangChain, and something like that. You can see here, right? According to the data provided, Chad has the lowest GDP per capita among all countries and regions listed with a score of 0.35. Fantastic, right? I liked it. It's just taking around 25 to 30 seconds, on average, to generate a response or retrieve a response or information from your data set that you have. So these were the data that we have taken. You can see the data that we have over here, and this is the data. Not much of a complex data, but you can see a complexity also, guys. You can find it out, that one. So this is fantastic, right? I just wanted to see that if we can build something like this, and just to show you something. Let me just see Chad. You can see Chad over here at 0.35. You can see 0.35 as the GDP over here, which is very less, and that's the response that we got over here in our chat with CSV using Llama 2. That's it, guys, and I think that's all for this video. Now you have two videos, and I am going to create two more videos on Llama 2. One is on Llama 2 deployment on AWS, and the second one is containerizing this through Docker and deploy it on any cloud, right? So two more videos on Llama 2 will be posted soon on the YouTube channel, and please stay tuned for that if you are interested. So let me know if you want to extend this further, if you are extending this with some charts or some plots within this. Please let me know. I would like to see that what you do with this, and if you have any thoughts or feedback for me, please let me know. I'll be more than happy to take the feedback and incorporate in my future videos to improve it further. So that's all for this video, guys. Not wasting any more time on this. of yours. So please go ahead and get the code from GitHub and try to implement it on your data and let me know your views on that. That's all. Thank you so much for watching. See you in the next one, guys.